Okay, I was going to put a video up here real quick about some of these square roots because I had some students asking about them the other day. So on the test review, it's on there as well. We want to look at simplifying these square roots. And what you have to do is look for these perfect squares. It's all based off these perfect squares right here. So these right here, the bigger numbers here, not 1, 2, 3, 4, 5, 6, 7, but 1, 4, 9, 16, 25. These are called the perfect squares. If you can break this number and down into two numbers with multiplication, what we call the factors, if you can find two factors of that number, one of them has to be a perfect square. Because if you take the square root of 4, you get 2. If you take the square root of 9, you get 3. If you take the square root of 25, you get 5. Take the square root of 49, you get 7. So that's what we want to, that's the goal, okay? So, like 20, you could say 20 is 10 times 2. Well, neither 10 or 2 is a perfect square. You can't take the square root of 10 or 2 and get a whole number. So what you're going to use then is 4. 4 times 5. So you got to know your multiplication tables. So 4 times 5. So you can rewrite it like that. Well, the square root of 4 is 2. So that 4 gets to come out as a 2, but the 5 still stays in there. So the square root of 20 is equal to 2 square root of 5. And you can plug in the square root of 20 in your calculator and 2 square root of 5 and make sure you get the same number. That way you can check your work. 75. Well, that's 3 times 25. I like to write it like this. But the square root of 25 is 5. It comes out. But the 3, it's got nowhere to go. It stays inside. The square root of 162. Well, if you go down through this list, I mean, 4 might go into it, 16 might go into it, but you got to pick the biggest number that goes into it. 81 goes into it twice. 81 times 2 is 162. So 81 times 2, that's how you break that down. The square root of 81 is 9, and the 2 has to stay in there. If you think I'm going too fast, just rewind it, pause where I'm at, and try it out. These are the even questions out of the textbook, by the way. It's on page 267. That's where this is at. Okay. The other thing is to add or subtract these, and if you have the same radical, that's nothing more than just combining like terms. So you don't worry about your answer has radical 5 in it. It's the same radical here, it's the same radical in the answer, but 3 plus 2 is 5. Simple enough, right? So as long as you have the same radical, you can just add or subtract the front numbers, the front coefficients, just like in combining like terms. These guys are not the same, so we need to simplify these to see if we can get it to the same. 18 is 9 times 2, and I'm getting 9 from here. Okay, I've got to use one of these perfect squares, the biggest one I can find. Now remember, there's still a 2 out here. Well, the 9 comes out as a 3. So it's going to be 2 from this 2 right here times 3, which came out of the 9. So here's the 2, here's the 9, it come out, but there's a 2 still left in there. And whenever you bring something out, it's always multiplying. It's always 2 times this. It's always 3 times this. 2 times 3 is 6. So you get 6 square root of 2. This guy, well, 50, that's 25 times 2. Right? Well, 25 comes out as a 5. So you got minus 3 times 5. That comes down as a negative 3. That comes out as a 5. And the 2 is still left in there. Well, negative 3 times 5 is negative 15 square root of 2. Well, look, now they have the same radical. So that means that if these two are the same, then my answer has a square root of 2 in it. And then 6 minus 15, well, that would be, what, 9? Negative 9? So negative 9 square root of 2. If you got any other questions, just email me. I'll try to shoot you a video or something. Thanks.